Well, hello, welcome along. It's a brand new episode of the Fun Kids Science Weekly. My name is Dan. Thank you for finding us, for pressing play, for streaming and telling all your mates, of course. This is the smartest show in the universe. Together, you and I, we will travel all around, we'll search around the solar system, we'll go through the galaxy to find all the most amazing science things that's lurking about. Alright, and this week we're travelling back in time to the age of the dinosaurs, looking at the Cretaceous period, and we'll find out what happened when a new creature began to take off.
Quick, that's not a bird. It's a flying reptile. Let's get out of here.
I think we're safe here.
Also on the show this week, you can hear from a genius physicist about a new sun that we've made here on planet Earth and why it's making scorching temperatures.
And eventually we kind of want to get even hotter than that. So there's a milestone on the way, getting to kind of 6, 7, 10 times hotter than the centre of the sun.
Wow. And I've got your questions as always. This week they are on why we can't see in the dark, and we'll try to weigh the sky as well. Yeah. It's a big old thing. It's a big deal that it's happening this week on the Fun Kids Science Weekly. Stay there. Loads to come for you. It's time for this week's Science in the News. Now, experts have finally figured out when the asteroid that ended the dinosaurs struck planet Earth. Well, at least when in the year that it happened. It was about 66 million years ago, in the spring of the Northern Hemisphere. Now, they found this out by studying rocks and fossils in a place called Tanis, which is near where the asteroid struck. And they think it had a big impact on creatures around that time because it messed with the seasons. Fish would be thrown onto land, the temperature changed, and the sun would have been blocked too. Also, a dog kennel from Central America that was hit by a meteorite has sold for loads of money. The kennel belonged to a German shepherd dog from Costa Rica, and it was hit by space rock a few years ago. And last week, it sold for over £30,000. And finally, this is interesting, the International Space Station, something we've heard so much about on the show, it's been in orbit since 1998. It's only going to work for another few years, until 2030, and then it'll crash back down to Earth. You see, the ISS is getting old and it needs replacing. Parts have stopped working. And in early 2031, it will plunge into the Pacific Ocean at a part of the sea known as Point Nemo, which is the furthest point from land here on planet Earth. It's time to catch up with one of our favourite geniuses on the show now, Professor Hallux. He and his good friend Nurse Nanobot, they're having a look inside you at what might go wrong in your body, what makes you feel unwell, and also looking at the people and the places where you can get better. It's the Map of Medicine series. Now, in this episode, Professor Hallux finds out what happens when you get your appendix removed and what goes on in the operating theatre.
Professor Hallux's Map of Medicine.
Professor! It's that video phone again!
Call accepted.
Coming! Hallux's happy health. Help! Desk! Oh, I think I've pulled something. I need to lie down.
Hi, Professor Hallux. I'm not very well. I've got an appendicitis. It's a really horrible tummy pain right by my tummy button. It keeps on coming in waves and has been making me very, very sick. I'm going into hospital to have an operation to take it away. Can you tell me a bit more about what would happen in the operating theatre? Will my appendix be lonely without me? And why is it called a theatre?
Oh, you poor thing. I can tell you loads about all that. Or my Map of Medicine can. It's got shed loads of great info about medical places and people. I'll load it up while Nurse gives us the clinical crunch about unhappy appendixes. And you get yourself tucked up back in bed. That's an order.
Clinical crunch. Whoops.
The appendix is part of your digestive system between your tummy and your bottom. It's a wiggly little tube that looks a bit like a slimy fat worm. Yuck. But the really weird thing is no one really knows what it's for. On the plus side, this means that when it gets infected and swollen, it can be removed by a surgeon in a small operation, and your body can work just fine without it.
Yeah, but when they're really manky, they have to be whipped out, else... That's the appendix, not you. You won't explode, but you don't want exploding appendixes sloshing their germy gunk all over your inside, so it's best to have it out, and for that you need a surgeon. They're special doctors who've trained for a very long time to perform operations, which means to open up the body and fix things, just like a car mechanic, just with bodies, not cars. Clearly.
Professor, people are nothing like cars. They're a little bit more complicated than that.
OK, surgeons are absolutely nothing like car mechanics. Let's load up the map of medicine and find out more. Here we go.
Opening the map of medicine.
Here's how it all works. You'll be put to sleep by an anaesthetist who will give you a special medicine in an injection, or you'll breathe some gas. And it means you won't feel or remember anything about your operation. Blah! Sorry, just nodded off there. Often you're not allowed to eat or drink anything in the run-up to your operation. Bit annoying, that one. But just think of the big slap-up dinner you can have when you're home and better. So, once you're asleep, you're taken into the theatre. Not remotely like that. Operating theatres are just very, very clean rooms. You are carefully monitored to ensure things like your heart rate and breathing are stable. And then the surgeons and their theatre team cut into your body. Yeah, cut. Mostly with knives, called scalpels. Sorry about that. It's not nice, but there you are. They have to get in somehow.
Open sesame!
That definitely wouldn't work, but would be very cool if it did. Crikey, it's turning into a right pantomime here today. Actually, it isn't always knives today. Sometimes they use lasers, which is quite cool. Anyway, the surgeon uses special instruments to repair your body, and they have to be super clean. Many instruments are in sealed disposable packs to stop germs getting inside your body. Depending on what they're doing, surgeons occasionally use keyhole techniques, which means small incisions or cuts, and they use special cameras to see what's going on inside. That means they can see that rumbling tummy in super sharp detail on a big telly.
Now here on BBC One, it's time for a big rumbly tummy.
Some of their tools are very high-tech, like the lasers, and others are pretty basic, like saws, hammers and sutures. That's a needle and thread. What they use will depend on what the surgeon is fixing. Our minky-manky appendix is likely to be removed by a general surgeon. But other surgeons might specialise. That means they get really good with particular organs, like the heart, the liver, or the brain, whilst others are ace at fixing broken bones. Whatever the type of surgeon, once they're done, they sew things up neatly and then top up your oil and you're ready to roll.
Professor.
All right, they don't actually top up your oil, but you'll be monitored to make sure you're comfortable and taken into an area called recovery.
Recovering from an op can feel a bit strange. If you feel groggy or sick or upset, don't worry. It's just the effect of the anaesthetic wearing off.
That's right, you're in good hands. Remember, surgeons perform dozens of operations each week. That's hundreds every year. And you'll feel much better without an angry appendix giving you jip and making you barf. Let's have a quick disgusting detail, nurse. It's just time before we go.
Disgusting detail.
You know how important it is to wash your hands after using the toilet. It stops the germs from your poo and wee spreading about and making you poorly. The man who discovered that germs can pass around like this was called Joseph Lister. Thanks to his work 200 years ago, medical professionals are really careful to keep things clean, to help you get back on your feet as fast as possible. Before surgery, surgeons scrub for at least 3 minutes, during which they wash their hands right up to the elbow with special bacteria-killing soap. They're not allowed to touch anything dirty after they've scrubbed, which includes the taps, so they have to turn them off with their elbows. If the surgeon touches anything that isn't sterile, they need to go and scrub in again from scratch.
Time for us to go, but before you join us again, why not explore Map of Medicine for yourself?
Hallux's Map of Medicine is produced by Fun Kids with support from the Wellcome Trust.
Thank you so much to the proper Professor Hallux and his good mate Nurse Nanobot. They'll be with us again for a brand new look inside your body at the same time next week. Right now, it's time for some of your questions then. Remember, if you've got anything sciencey that you want answered on this show, you need to leave it as a review for me over on Apple Podcasts. First up this week is from Lucy in Scotland, who wants to know, why can't we see well in the dark? Well, I mean, simply, Lucy, it's because we need light to see. You've got cells in the back of your eyes that pick up light that's around. It senses when there are light photons nearby, and that sends a message to your brain which lets you figure out where you are and what's going on and what's happening. And objects around us as well, they reflect or absorb light, which shows if they're there and what colour they are. Now, in darkness, where there isn't any light, the cells in the back of your eye can't work out and can't see what's going on. So that's why you can't see well in the dark. Also this week, this is from Fifi, who wants to know, what a brilliant question this is, how much does the sky weigh? Have you ever thought about that before? The fact the sky does actually weigh of something. And because it's huge, it's all over the place, it's really, really heavy. Now, air is all around, and it presses down on us from all directions. If it didn't, and it was just over our head, it would knock us straight down to the ground. But you've got air to your right, to your left, up above, down below. It's all over, and that keeps you kind of equal. Now, the weight of all that air is called air pressure. It's measured at 6.6 kilograms per square inch of the Earth's surface. And if you times that by how big the Earth is, some smart scientists have done some huge calculations and sums. They figured out the weight of the sky is roughly 5.2 million billion tons. That means the sky weighs 1/1,000,000th of the mass of the Earth. So it's very heavy. Thank you so much for those questions, Fifi and Lucy. If there's something you want answered on the show next week, get yourself to Apple Podcasts, leave us a review. There's a little comment box. That's where you put your question, say hello with your name and leave us 5 stars so I can see it too. It's the Fun Kids Science Weekly. Now, you might have seen that China recently have made an artificial sun. It's a fusion reactor. It cost them $1 trillion, and it's made a world record temperature that's 5 times hotter than our sun. We're going to find out more with Hannah Willet, who works as a spectroscopist at Tokamak Energy, who research and develop fusion energy tech. Hannah, thank you very much for being there.
Hello.
I think I got most of those words right. Let's just start off. What is a spectroscopist?
Okay, well, spectroscopy is all about looking at light, basically. So spectroscopy has the same kind of root as spectrum. So light has a spectrum of all different energies. So we see visible light, which is a little part of the spectrum, which has our colours all the way from red through to purple in the rainbow. So that's kind of what I'm looking at, light.
How much don't we know about light? I always thought that we knew everything.
Well, so we're looking at light from a very specific object, from a very specific matter. So Tokamak energy, Tokamak is a fusion energy reactor. So we're studying the light that comes out of that experimental reactor that we have at Tokamak Energy.
What is nuclear fusion? We've heard of this artificial sun. I know that nuclear fusion is a lot of how the sun, our actual sun, makes its energy, which powers us down on Earth. Just tell us the whole thing.
Absolutely. So you're absolutely right. Fusion is what happens in stars and in our sun. And you're right that those fusion reactions create all the energy that the sun produces, and that reaches us here on Earth, like nearly 100 million miles away. So it's producing a lot of energy for us to be able to feel the sun's warmth and light on Earth. So what fusion is, fusing stuff together, it means kind of like sticking stuff together. So it takes atoms, right at the beginning, it takes atoms of hydrogen, which are the smallest atoms. So if you think about, I guess, in a helium balloon, right? Helium gas, you fill your balloon and then it floats. So it's a very light gas. It's the atoms, the tiny particles, the building blocks of matter. They're so small, they're really light, so they float. So hydrogen is like helium, but even lighter. Those are the tiny particles that get stuck together in a fusion reaction. And when that reaction happens, it gives off quite a lot of energy.
So, Hannah, why do these atoms fuse together? What is needed to make these atoms join, and why isn't it just happening everywhere?
So they need to be super close together. So you need them to be really, really hot and pretty dense. So you can kind of get like a balance. If you have in the sun's ridiculously big. So in the sun, because it's so big, there's so much gravitational force. All the gravity is kind of squashing everything together right in the middle. So everything's super close together already. And then it's also really hot. The center of the sun is about 15 million degrees Celsius. So that temperature and the density, all those particles being squashed together, means that the reaction can happen and those hydrogen atoms can get close enough together to fuse together. Because the thing is, they're actually positively charged. So positive charges don't like other positive charges. So to get them close together, you have to give them you have to put a lot of force in, put a lot of energy in to squash them together. So that's what happens in the sun. But on Earth, obviously, we can't make a real size sun because that would be a little bit too big. So we have to make these miniature suns. So because we can't get them quite so big, we can't get them as dense. We can't pack the particles in as close as they are in the sun. So we have to make them even hotter, which is why you said earlier about kind of 5-6 times the center of the sun. That's what we're aiming for in our experimental reactor at Tokamak Energy as well. And eventually we kind of want to get even hotter than that. So there's a milestone on the way, getting to kind of 6, 7, 10 times hotter than the center of the sun.
Wow! How do you possibly make things that hot? What have you got? Just like a massive stove somewhere?
Not quite. So that's where the tokamak comes in. A tokamak is a special name for the kind of reactor that's used quite a lot in fusion research. So if you think about like a ring donut or maybe a cored apple, so something that kind of like wraps around on itself and there's a hole through the middle, that's the shape of the tokamak. It's basically like a donut-shaped reactor. So to make our hydrogen fuel that hot, first we need a vacuum. We've got to take as much air and other particles out of that tokamak reactor, out of our donut, as we can, to make sure that there's nothing there for our plasma, for our hydrogen fuel to crash into, because that will take away its energy and make it cool down, which isn't good. So in our vacuum, in our donut reactor, we can put in our hydrogen gas fuel, and then to make it heat up, well, we use a lot of electricity. Really, we can put big currents through to help heat it up. We have magnetic fields to hold it in place, which is a bit like holding a jelly in a net, quite frankly, which is why it's quite difficult. So we're trying to hold this really, really, really hot gas, which we call a plasma, in a magnetic net inside a tokamak donut-shaped reactor. We run electricity through it to make it hot, and we can also put in other energetic particles. So we have what we call neutral beam injection. So we're putting in beams of particles that are neutral. They don't have any electric charge, but we make them travel really fast. We accelerate them, and then they get injected in to help transfer some of their energy to the plasma to keep it nice and toasty warm.
Now, why do we do this? Why are we making these reactions, these fusions on Earth? What's the point?
That's a good question. I mean, it's super interesting, but it's also super important for kind of generating electricity and meeting humans' energy needs kind of going forwards. So fossil fuels like coal, oil and gas, we are kind of running out of them, really. There's finite resources. There's only so much coal and stuff we can dig up. And then when we burn those, we get all kinds of nasty stuff that gets released into the atmosphere. So carbon dioxide, for example, and other greenhouse gases. So that's what's contributing to global warming. So if we can find other sources of energy instead of fossil fuels, then that's really going to help us out going forward. So there's other things like wind power, solar power, that are renewable sources of electricity, but they obviously rely on when the wind blows or when the sun shines. So they're really good, but fusion could have the potential to be a much more reliable in the sense that you can just like switch on the machine and then you get some electricity. But if you didn't need it, you could switch it off again.
Let me just ask, and I know that you work for a nuclear fusion reacting company, but sometimes you hear in the news people opposed to nuclear fusion. What are some of the disadvantages with creating energy this way? Are there any?
Not really, to be honest. I mean, I think sometimes people see the word nuclear and it's a little bit scary because it is quite complicated science. And then I suppose there's nuclear fission as well, which is the nuclear power plants that we tend to have at the moment. I mean, nuclear fission is also a good source of energy. I don't want to get into a fight between the two. But I think one of the problems with nuclear fission is that it does create a lot of radioactive waste that lasts for a long time.
So you're different things.
Yeah.
That's the confusion that I was getting. Lastly, let me just ask you this. When you make something get that hot, what happens? What I mean is when I heat water up to 100 degrees Celsius, it will boil and it will turn into steam. When I heat wood, it will make a fire, which glows, which makes gas glow orange and blue colours.
That's actually a plasma as well. Fire is a plasma.
So this reaction they've got in China that they've made go to 5 times hotter than the sun. I know you're aiming for more than that someday. How will that heat present itself? What would happen if I stuck my hand near it?
So you'd have to get inside that vacuum vessel to stick your hand in it. So you're not really going to get that close to it, to be honest. But as soon as... So what happens is, so you mentioned heating water to make gas, to make steam. So we think of solid, liquid and gas as the 3 states of matter. But actually plasma is the 4th state of matter. So you heat a solid like ice and you get water, a liquid. You heat that water and you get a gas, you get steam. So then we're heating a gas even more and we get plasma, which is the 4th state of matter. So what actually happens is you start kind of breaking those atoms up a little bit. So an atom has a middle, a nucleus, and it has electrons, which kind of fly around the outside, a bit like planets orbiting the sun, I suppose. And when you heat it up even more, you take some of those electrons off. So you end up with this kind of soup of electrons and the middle of atoms. So there's a lot of electric charge and it's a very complicated kind of substance to understand, I suppose. But that's what happens when we have that much heat, that higher temperature.
What does plasma look like very quickly?
Plasma, so kind of like you said, like fire. So fire is a kind of plasma. Your neon strip lights in classroom ceilings or on neon signs, they've got plasma inside them. So you've made your atoms really hot and then they start emitting light. So depending on how hot it is, it emits different colors of light. Sometimes it emits light that we can't see, UV light, which has even more energy than the visible light that we see.
Amazing. There is so much to get your head around. I'm so happy, Hannah, that you've explained it to us. Hannah Willet, who is a spectroscopist at Tokamak Energy, thank you for joining us. It's time for this week's Dangerous Dan, where we look at some of the most mean and deadly things in the universe and through history. And this episode, it's all about something brand new that's somehow 70 million years old. You see, scientists have discovered a brand new species of dinosaur. It's a type of Abelisaur. The fossils were found in South America, in Argentina, but at the time, all those years ago, it would have roamed in Australia and Argentina too, all around the southern hemisphere. And it looks pretty strange, this Abelisaur. It's a huge, big, striking creature, gigantic, 30 foot long. Now, it looks a bit like a T-Rex, but if you can believe it, it had even shorter arms. It has a huge swinging tail as well, massive stamping feet, and these tiny arms. Now, it was almost armless, but certainly not harmless. It made up for it with a ginormous jaw with thick, sharp teeth, which it used to attack. That was what it had in its arsenal. And its long neck would have helped that. It would have swung down with its gigantic dagger teeth, slicing any prey that came nearby. It was the only way that it could feast, to ravage another creature using just its teeth. Think of how deadly and menacing that would have been 70 million years ago. Which is why this brand new discovery, the Abelisaur, is going straight on our Dangerous Dan list. It's time to have a listen to the series which helps us time travel. It's the Age of the Dinosaurs. Now, you might remember last week we had a look at all the dinos and the creatures that were under the ocean. This week, as the Jurassic period came to a close and the Cretaceous period began, we saw a new type of creature that was starting to take to the skies. Birds.
Imagine going back in time, not 100 years or 1,000 years, but millions of years. To the Age of the Dinosaur. Welcome to the end of the Jurassic period, 145 million years ago. As the Jurassic period came to a close and the Cretaceous period began, many new types of animal and plant life were evolving, and a new kind of creature was starting to take to the skies. Birds.
Watch out, something is swooping at us.
Wow, it's an Archaeopteryx, the first known bird. Only 10 fossils of the Archaeopteryx have been found, but they're important because they prove that birds evolved from dinosaurs. However, they were very different to birds we know today. The Archaeopteryx was the size of a crow. Whilst they had feathers, they also had teeth, claws on their wings, and long tails. They also weren't great flyers, more likely to glide for short distances rather than flap about.
Phew, he hasn't seen us. He's perched up in the tree.
Being able to hide in trees is a great way to stay safe. It's believed that small dinosaurs evolved into bird-like creatures either to help them escape from predators, more powerful dinosaurs who preyed on smaller and lighter creatures, or to help them go after prey that lived up in trees, such as insects and small lizards. To survive over thousands of years, these small dinosaurs evolved. They grew long but light feathers, and their front legs got longer to form wings that would help them fly. Other dinosaurs grew feathers, but as they stayed too large and as their arms weren't strong enough, they never flew. One such dinosaur was the Dilong, which was the same size as a dog. Although he couldn't fly, his feathers would have helped him keep warm and might have allowed him to show off to other Dilongs when competing over territory or mates.
Quick, that's not a bird. It's a flying reptile. Let's get out of here.
I think we're safe here. Along with the early birds, pterosaurs ruled the sky. Pterosaurs didn't have feathers. They were flying reptiles with strong arm muscles and wings made of thin skin. But don't worry, that's a Rhamphorhynchus. He's mostly interested in sea life. He flies low over the lagoons and uses his pointed beak to grab at fish and other small creatures.
Paleontology, pick.
When all that's left behind are fossils, it's hard to say what colour dinosaur skin or Archaeopteryx feathers were. Recently, scientists have discovered small parts of pigment cells called melanosomes. Through the use of clever technology and comparing results to today's animals and birds, they can make some amazing discoveries. For example, they now know that the Sinosauropteryx, a small bird-like dinosaur, had dark-coloured stripes along its tail and an orange-coloured crest along its back.
And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening, for streaming, for downloading, for following, for telling all your mates. I love the fact that you're there with me every week on this journey to learn so much about the amazing universe that's around us. Now, if you want a question answered on the show, for the next week or so only, leave it as a review over on Apple Podcasts. Because after that, we've got a very special brand new way that you can actually be on this show. Keep your ears peeled for that. It's on the way. I'll let you know more when I can. I'm so excited for it. Also, you can follow so many of our brilliant podcasts that we make on Fun Kids on Apple Podcasts. They're on Google, Spotify, on the free Fun Kids app and at funkidslive.com. And Fun Kids, we are a children's radio station from the UK. Listen to us all around the country on your DAB digital radio, on that free Fun Kids app and at funkidslive.com.